Hey everyone, in this video we're going to look at data transformations. So basically when your scatter plot or your association between numerical variables is not linear, so we need to transform the data to linearize it to make it fit a straight line. So we're going to look at this assignment. There's quite a few parts involved because we do have to test each transformation, and you won't have to really do this on an exam because it is quite a lengthy process, and on an exam you've only got a finite amount of time that has to test everything. So you might have to do what type of transformation or use the transform to regression equation, but you wouldn't do this level of analysis, but you are expected to be able to do it in a SAC situation. All right, so for this assignment, we're looking at country and their life expectancy and GDP. So life expectancy just means how long on average someone is expected to live in that country. So for Afghanistan, it's 65.17, Australia 83.2, and so on. And then for GDP, that means gross domestic product, and that's just a measure of the wealth of the country. So again, for Afghanistan, it's $516.75, and then Australia is quite a bit higher. Now, when you're being asked to do transformations, it's highly likely that your scatter plot is not linear. So that's why we transform it. So if you're kind of assuming that it's linear and it's not, then there's no point in doing it. So you only do transformations basically if it's not linear. If it's linear, then we don't need to transform it. All right, so we're going to put all this data into our calculator. So we go to statistics. Now you should have list 1, list 2. You can clear everything from there like that. Now you can also set up your calculator before your SAC or before your exam to have different variables at the top. So if you're preferring, instead of using list 1, to use X, because that just helps you remember which one's your explanatory variable and which one's your response variable, you can just highlight it and replace it with X. Now, if you've used this before and numbers start appearing, you can just go to Edit, Delete, and Delete Column. So go, okay. Now, it's probably a good idea to start off with a clear window or a spreadsheet before you start your SAC or before you start your exam, just so you're not wasting time clearing it or deleting. So if you're going to relabel your columns, you need, and numbers appear, they won't appear because I've already deleted them, but going through and deleting each one during an exam or during a SAC is probably not a good use of your time. So making sure they're set up beforehand is good. So we've got X and Y. Now you can also do all your transformations. Now the problem with that is if you do residuals in here, then it can get a little bit problematic. So you really need to get familiar with using the spreadsheet. So I'm going to go ahead and put all the transformations in. So we're going to have X squared, then we're going to have Y squared. You can use XX or YY instead of XSQ, whatever you want to use, as long as you remember it. Now, the calculator doesn't like symbols, so if I did x to the power of 2, it doesn't like it. So we do need to make sure we use just letters basically, and doesn't like spaces. So if I'm doing log x, I'm just going to write it like that. Whatever is going to help me remember. All right, and then you might run out of space. All right, and you're like, well, I haven't done my reciprocals, so just this button up here is going to add some more in. So then we can do the reciprocal of x and then reciprocal of y. Now, if you want to, so notice I had already done that for another question. So I'll just show you, go into Edit, Delete, and Delete Column as opposed to clearing everything, because once you clear it, it's going to rename your lists. Now, if you want to, you can also put, let's go, you're going to add another one for me. You can always add one for residuals if you like. And that's it. I'm getting confused with the other calculator because the other calculator does put data in. All right, so when we're putting our variables in, make sure you know what your X and your Y are, so your explanatory and your response. So you can get that sometimes from what you're predicting, or have a look through. So during reading time, I would look through for a scatter plot, because if you've got a scatter plot already given to you, then that's a clear, that it just tells you straight away what your explanatory is and what your response is. So let me just fold my laptop over. Sorry. So remember, you're always going to have your explanatory variable on your x-axis and your response. So if you're given a scatter plot in addition to a table, then you can read it straight from that. We don't have that for this question, so you can maybe figure it out from the table. What comes first, life expectancy or the wealth of a country? Or we can have a look here. We are predicting life expectancy. We're always going to be predicting our Y, all right, our response variable. So life expectancy is our response. So I'm just going to do RV, which is our Y, and our gross domestic product is our explanatory variable. And when you think about it, the wealthier the country, probably you're going to live longer because you've got better health facilities, probably better job prospects, stuff like that, that do kind of attribute to living longer. We don't live for a certain age and then the country says, oh, you know, the life expectancy has now gone up to 90. Now our wealth has changed. All right. So your gross domestic product is your explanatory variable, and that does impact your life expectancy. But it also, if you look for what needs to be predicted, like in the stem of the question, if I just go down, we're predicting life expectancy. We're always predicting Y. All right, so go ahead and put those values into your calculator. Remember, we're going to be putting gross domestic product with X. All right, what a time-consuming process putting all those numbers in. Now, it's because we've got a long process to follow, it's probably a good idea to check all your numbers. You'll notice for mine, because some of the numbers are quite large, you won't see all the digits. So if you press on the number, you can see it. So when you're checking, you can just scroll down. We'll just make it easier. I haven't checked it because, you know, it already took me ages to put it in, and we've got a lot to do in this video, but you should have put them in. You shouldn't be just listening to this, but doing it at the same time. So if you haven't done it, pause this video and put them in, please. All right, so let's have a look at question 1. We wish to predict life expectancy from GDP. Which would be the response variable and which would be the explanatory variable? Okay, we've already done that. So life expectancy is our response and GDP is our explanatory. So we're always predicting our response variable. All right, we're going to construct a scatter plot of life expectancy against GDP and describe the association in terms of direction, form, and strength. So getting the calculator. All right, so to draw a scatter plot, we just click on that button there. It looks like the graphs. All right, and your X and your Y, we're no longer in list 1 and list 2. Remember, we called them X and Y. So I can just go down to X and down to Y. All right, there's nothing else that needs to change, so I'm just going to go, all right, let's undo that, and then we'll have a look at our graph. So we can clearly see it is non-linear. So when we're talking about it in terms of direction, it is positive. The form is non-linear. And when we talk about strength, we can't really interpret the R value unless it's linear. But if you wanted to interpret the R value, then you can just go to analysis, go back up here, calc, regression, and then linear reg. And remember, we're doing X and Y. Go okay, and your R value will interpret that for you. So 0.7 is moderate. So even though we don't, all right, my recorder was just flashing at me and I was a bit scared I was going to lose something. All right, so yeah, we usually don't interpret it for nonlinear data, but if you're asked to, just interpret it. So it is moderate in terms of strength. All right, use the circle of transformations on page 239. So that refers to your textbook. I wonder if it's the same page, whether they've updated it. And and confirm the transformations to be y squared log x and 1 over x. So I should have the transformations. Oh, it's flashing again on me. Okay, I don't know why it's flashing. All right, so your circle of transformations is this here. So our scatter plot follows this top left corner. So we're just confirming that it's y squared log x and 1 over x. The reason this question has told us that it's those three is because, you know, it's also going to tell us what transformations to do. So if you weren't told which transformations to do, you do need to look at this circle of transformations. So just matching the scatter plot. So if I go back to the scatter plot here, just ignore that regression line that's popped up. So see how it's the top left corner. All right, so we do y squared log x and 1 over x. So y squared log x and 1 over x. Okay, moving on to question 2. So we're looking now at each transformation. So you'll notice that the questions are pretty much the same thing. All right, so questions 2, 3, and 4 are doing doing the transformation and checking it. Oh, someone's just at the gate. It's always a good day when Lucy makes an appearance and the Amazon delivery driver. All right, so we're going to, I can't remember where we're at. So we've got y squared transformation. We're going to do that one first. So on our calculator, if I just go back to my table, now remember to see the whole thing, we can just go to resize. So we're doing y squared. So that's x squared. So I can go across to y squared. Now I want to tell it what to put in this column. So I do that down the bottom. So see where it says cal, short for calculate. And then we want it to square y. So we go y to the power of 2. So just notice how I've calculated it there. So your power button is here. All right, and then it's just squared all those values. All right, so we're going to construct a scatter plot, now doing life expectancy against GDP. So just to make sure we remember, so this is our y squared and x. So when we do our scatter plots, only one of the variables is transformed at a time. All right, so we go to scatter plot again. The x can stay, but we transformed the y to y squared. So I'll put that on, go to set, and then we can have a look at our graph. All right, so there is the graph of, no, I don't think that changed. Hold on one second. Let me just make sure it's all right. Okay. Didn't look like it changed. All right, so it is actually, I probably need to switch because I was just playing around for a little bit. It does look the same, but the thing is we can't see what this scale is here on this side. So I'm going to just show you, we can look at the scale on our calculator. So if we go to, just click on the graph and go to where you've got these arrows, you can check your scale there. But when you're making a decision as to which transformation is best, a lot of it is just done by sight on your calculator. If you do need to sketch it, you probably just want to show that it is curved. All right, so if I just scroll down, because I did check my answers down with the answers on here. All right, so there's our original scatter plot. And if we compare it to the other one, see, it does look pretty much the same. It's just the axis has changed. All right, so we can see that. So we changed the axis from life expectancy to life expectancy squared. All right, so it's kind of just shifted all these values up the y-axis. So if we look at this value down here, which is probably around 58, all right, now that's up at 58 squared, so whatever that is, just over 3,000. All right, let's go back. So we've done our scatter plot. Part B, fit the least squares regression model, which enables life expectancy to be predicted from GDP. Write down the equation of the model, giving the values of the coefficients rounded to 5 significant figures. All right, so going back to the calculator. So if you're doing any regression model, so it would say least squares line as opposed to regression model, but it's the same thing. So we just go back to our spreadsheet, go to calc and regression, and we're doing linear regression. Just got to make sure that we're consistent with our x and our y. So remember for question 2, for our y2 transformation, we're doing x and y squared. Where are we? There we go. We don't need to do anything else here. We just go OK. So we can get our regression equation from here. So you should be writing this down as you go along. All right, so you would, let me just fold my laptop over. So you've got your type of transformation is y squared. All right, your equation. Now remember, we use the variables in the question, so not y. So our y is life expectancy squared, and you can see it written there. So life expectancy, I'm just going to shorten it because I won't fit it all in otherwise, is equal to, and then we still do our value of a, but we're doing it to 5 significant figures. So it's going to be 4866.7. So we've got to round that 6 up. Remember, if you have trouble with rounding, you can use the S round function as well. So 4866.7. And then we've got our slope, which is quite a few numbers to remember. 37214. I'm going to have to write this down. 37214. All right, so we've got, I'm just going to have to put it underneath. So 0.037, so remember we only count the significant figures. All right, so those 0 and the 0 stay, but we've also then got to include 5 significant figures, and then that's times GDP. All right, so a bit squishy there, but there's your equation for the y squared transformation. All right, construct a residual plot and comment on whether the linearity assumption has been met. So to check the best transformation, we look at both the residual plot and the R squared value. So if I just go back here, go okay. Oh, I should have written down the R squared value. Actually, I know this isn't going to be one, but I'm going to go back and just quickly write down the R squared value because I should have done that before. And sorry guys, sometimes when I have my computer folded over, it doesn't like me using my laptop. All right, so my R squared value, you can see we're going to do it in part D. So that's what so when you've got this screen up, it's probably a good idea to write it all down as well. So determine the value of the coefficient of determination. So remember that is your R squared. Give your answer as a percentage rounded to 1 decimal place. So R squared is 0.527. So when I multiply that by 100, I get 52.7. And that's as a percentage. In your SAC and in your exam, you're allowed to take your scientific calculator as well as your CAS calculator. So if you want to have that separate to do other calculations while you're in your data screens, you can, all right, instead of going back and forth. All right, part C. Yeah, so let's do our residual plot now. Okay, so we go okay. And it hasn't put residuals in, so let's go ahead and do that. So if we're doing a residual plot, we do have to do, actually, I should have done it here. Sorry, guys. So going back, putting y squared in. And then we do want to put residuals. And remember, we had a spot for residuals, so I'm going to put them there. All right, it's a bit hard to see, but I can see the RES, and I know it can't be anything else. All right, so we go OK. All right, so we get the same thing as before. Beautiful. Now all it's done is put our residuals here, so that when we plot our residual plot, we can the values are there for us to plot them. All right, so we're going to sketch our residual plot. So it's a scatter plot. Your residuals always go in your y. So it doesn't matter which one we transformed, your residuals are always in y. We go down, there's our residuals, and there it is. And don't forget, we've got to click that to see our residual plot. And as expected, it's not going to be randomly scattered because it was still curved. All right, so it's not randomly scattered, it's showing a clear pattern. So when it says comment on whether the assumption of linearity has been met, no, it hasn't, because the residuals aren't randomly scattered. So let's have a quick look. I'm just going to scroll down to the solutions because you're probably keen, because I'm not writing them down. Where are we? Yeah. So the linearity assumption is not met, as there is still a clear pattern in the residual plot. So we got the same residual plot on our calculator. Notice the residuals on the y-axis, it says residual of y squared. All right, so just making sure that you're consistent with how you label it. All right, so let's have a look at the next transformation. So we go through that whole process again. So on the calculator, going back to your spreadsheet, go to resize. This time we're doing a log x transformation. So I've already got it written there, so I don't have to put it in, but you can if you haven't already got it there. And down the bottom, we tell it what we want to do. So your logs are where your keyboard, go to log base 10 and then comma y. All right, I don't usually edit a video, but I went 3 minutes in through the video, realizing that I did log y, not realizing I did, log y, and it should have been log x. And I got this residual plot and then I was very, very confused. So I had to go back. So I did edit this video and hopefully you realize that error because I did not realize it before. So there's all my incorrect log values. I'm just going to go back and change that. It should be log x. All right, always make sure you're paying attention. Maybe the Amazon delivery driver distracted me. Maybe I can blame him. All right, so we should have, just to make sure it's right, so log of 516 is our first, hasn't written as an exact value, that's written as expanded, that's all right. Just going to go across, all right, just to make sure that it has done that, beautiful. Okay, I'm going to go through that whole process and you'll have no idea because I deleted about 3 minutes of the video. So we're going to construct a scatter plot of life expectancy against log GDP. So y and log x. Write it next to your variables if you're going to get confused, and I obviously did. All right, but I realized soon enough that I had made an error because I wasn't getting what it should have looked like. All right, so we're going to do the scatter plot, log x versus y. All right, so make sure you've got them around the correct way. And then we go here. Oh, before when I did it was a perfect straight line. I was like, oh, that's crazy. All right, that looks a bit better. All right, a bit more randomly scattered. So we have to talk about the direct form and strength. Okay, so you should be able to do that. Remember, with your strength, we usually just talk about the R value if it's linear, but we can go ahead and do that anyway. So x is log x. Y is y, and I'm just going to put the residuals also in to the residual column. All right, so you can just see the RES there for residual. All right, so our equation, so our y is life expectancy equals A. So A is to 5 significant figures. I assume it still wants it to 5 significant figures. 36.324 plus your slope, 9.7632. All right, so that's to 5 significant figures. Also write down your R squared value. So that's 77.3%. All right, so writing them down as you go. All right, it does fit the regression line as well. We're also going to plot the residual plot. So we're going to go back and do log x and residual. So your residuals are always on your y-axis. All right, and then plot that. And we can see it's randomly scattered, so a bit different to the previous one. All right, so let's have a look at the answers to question 3. All right, so there's our scatter plot with the regression line on there. It has interpreted the association in terms of strength, direction, and form. And then we've got our equation there, which I read out to you before. All right, just making sure you keep your variables consistent, and in terms, you're not using X and Y, you're using life expectancy and GDP. Here's our residual plot. So remember, we put the residual on the y-axis, and you can see it's randomly scattered. So it says the linearity assumption has been met as there is no pattern in the residual plot. And then we've got the R squared value, all right, which we calculated. All right, last one we're going to do is where are we? All right, the 1 over x transformation. So pause the video and have a go at doing it on your own. I'm not going to do it on the calculator. I'm going to show you the answers, but you need to be able to do it on your own. The process is exactly the same. The only difference is we're now looking at 1 over x. So we're just going to go to reciprocal of x. So we go there, and down the bottom of the column, I might just resize it so we can see it a bit easier. We do 1, and then you can just do divided by x. All right, and there it is. I should have told you also, probably at the start of the video, your x and y, don't use this x and y. You need to use the x and y from the keyboard. All right, hopefully you haven't got to this point and didn't realize that. All right, so pause, have a go at doing all those questions, those 4 questions there. It probably will take you about 5 minutes to do. All right, and then press play again and I'll go through the answers. All right, so the answers to question 4. So just going down. So here's our scatter plot for 1 over GDP. You can see that on our x-axis, and life expectancy on the y. There is a weak negative linear relationship. I don't know whether it's linear. It looks a bit bunched up there. All right, but it's calling it linear, between life expectancy and 1 over GDP. Whoops. I guess because it's not showing a curve. All right, so life expectancy is equal to, so when you did your regression, you should have got these values to 5 significant figures. Just making sure your variables are written as the variables, not x and y. All right, here's our residual plot. All right, saying there's no pattern, so the linearity assumption has been met. And then we've got our R squared value. All right, so I might, just in case you haven't already seen the answers, I'm going to just slowly go through. So there's question 1, and you can pause, obviously. Question 2, and there's C and D from question 2. Question 3, and there's a residual plot. And then question 4, and there's our residual plot and our R squared value at the end. All right, Lastly, question 5, bringing it all together, the whole purpose of doing that process. So based on previous analyses, recommend a regression model for the association between life expectancy and GDP. So basically you want the residual to be so no pattern, or randomly scattered, so no pattern in your residual plot, and a higher or the highest R squared value. So if we have a look at the 3 that we tested, all right, so here is our, what was the first one? Y squared transformation. Our residual plot showed a pattern, which is not what we wanted, and the R squared value I know is the lowest out of the 3. All right, so it's probably not best to do a Y squared. Then for the log of X transformation, so your residual plot, it's randomly scattered, there's no clear pattern, and it's a higher R squared value, 77.3%. And then for the 1 over X transformation, there's your residual plot. All right, there's no clear pattern, although this bunching up isn't the best, but it's okay. And your R squared value is a bit lower at 61.5%. So if we have a look at the answer, just quickly for question 5, since the coefficient of determination is highest or higher for log X transformation and the residual plot shows the linearity assumption is well met, the recommended transformation is log X. And then you can write the equation. All right, so this is the model we would use. All right, so we're transforming our X values. All right, then in part, sorry, scrolling all over the place, use your recommended model to predict, rounded to 1 decimal place, the life expectancy of a country when the GDP is 20,000 and 80,000. So what we do is we take our model, our transformed model, and just substitute those values in. So just so I can go to the, use the model, I'm going to go to the answer for that. Where are we? There it is. Oh, don't want to give you the answer. All right, so going to your main screen, I might just clear what I've had there because I've got a lot going on. All right, so we're just substituting in for GDP, and it's flashing at me. It flashes at 10 minutes. There must be something that doesn't like it at 10 minutes. 36 point, so I'm just using this model down here, 324 plus 9.7632 times, and then we're going to do log base 10. All right, so don't worry about this log here, just the one underneath it, log base 10 of the GDP. So the first one we're going to substitute in is 20,000. So we should get 78.3. So 20,000, remember we're predicting it when GDP is 20,000. Oh, and it gives me that exact value. So I'm just going to change it to decimal, and there we go. So 78.3 years. So if you had a GDP of $20,000, the life expectancy is predicted to be 78.3. Now we're going to do exactly the same thing. So instead of writing it again, I'm going to highlight it and drag it down. And then we're doing it for 80,000. All right, so obviously if you're going to earn, as a country, earn more, your life expectancy is going to be higher. So it's predicted to be 84.2 years. All right, now part 5C is comment on the reliability of your prediction. So if you're ever doing reliability of a prediction, it's referring to interpolation and extrapolation. So remember, interpolation is within your data set, extrapolation is outside of your data set. So 20,000 and 80,000, let's go back to our data set. So GDP, I don't know what the lowest is, 438, and then our highest, Singapore looks quite high, 60,000. All right, so 20,000 is between those two values. So you're interpolating. It's interpolation within the data set. It's pretty accurate. If we did 80,000, so oh no, here we go. US is 63,000. So 80,000 is clearly above. All right, so it's not as accurate, and you're extrapolating. So it's not as accurate because you're outside of the data set. Think about taking this and let's say, well, what if a country was extremely wealthy and they had, I don't know, maybe 100,000. Did I just add another million? Yeah, I did a million. 100,000. I was hoping it would be a lot. Let's do 1 million. All right. Let's say the GDP was 1 million, which is extremely high. Have a life expectancy of 94. Imagine that. So most people in the country would live to 94 years old. So see how as you get beyond the data set, it's going to be less and less accurate. So maybe if I made it 10 million, all right, live to 100. So this is on average. This is not your highest person. So you might be sitting there like, oh, my grandma lived until 104. No, this is like on average. So in our class, most people would, if we were doing this, would live to over 100. But in reality, it's got here 83.2. All right, getting off track there. So I'll just scroll down to the answers to part 5 because I know some of you would be interested in actually what the answer is since I'm not writing it down. So the prediction for GDP is for $20,000 is interpolation and should be reliable because it's within the data set, and then 80,000 is extrapolation, so it's not as reliable. All right, so it may be unreliable. All right, there we go, guys. Bye.